Okay, we are going to be learning how to prove that triangles are congruent. And this page is not, I believe it's 6, okay, in your ISN. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. What that is called the side-side congruence postulate. So in this diagram, side AB is marked with a single mark. The corresponding side on the other figure, it's AB, would be RS. Okay, it's marked the same. So AB is congruent to RS. Side BC is congruent to side ST. I'm being picky about the order of my letters because I want the segments to correspond correctly. CA, so it started at C, went to A. How would that go on the other figure? It would be TR. Okay, so segment CA is congruent to segment TR. So now what's really important is the triangle congruence statement. So triangle ABC, if you go from A to B and then to C, how would that go on the other triangle? It would be R to S and then to T. So triangle ABC is congruent to triangle RST, and that would be by side, side, side. Okay, so order of the letters will matter. Using C, this is not the next page. Sorry, I gotta find. I believe it says the SAS. I know I got somehow these came out of order. This one, that's what's next, right, on your ISM? Okay, so there's another one, and we're actually going to be learning 5 different ways for proving triangles are congruent. This is called side angle side, SAS, and that's saying if 2 sided sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Okay, 2 sides and the included angle. What does included angle mean? It means the angle between the 2 sides, the 2 congruent sides in particular. So included means between. Okay, so in this diagram, segment RS is congruent. Now see how R has one arc mark on it? That would correspond to U in the other triangle. So if it says RS, it would be congruent to UV. And you see the double tick mark on that side. So this would be RS is congruent to segment UV. Angle R is congruent to angle U. Okay. And side RT with a single mark would be congruent to side UW. They said it's a W, right? I thought someone said UV. Okay, so then if we want to name fill in the congruence statement, it says triangle RST. So how would it go on the other triangle if it's already been started, RST? I'm not saying that's the only correct way to do it, but since we're already led to start with R, go to S, and then to T, on the other triangle, it would be U to V and then to W. Okay, my pen is doing wacky things. So that's going the same direction by the marks. U, V, W. And that would be by, you see how the angle is between the sides? It's smushed in between the 2 sides? SAS. Okay, you have a side, then an angle, then a side. Over here, you have a side, then an angle, then a side. That's why it's side, angle, side. Okay? Now, these examples, you have parallel lines here. What would that mean about angles 1 and 2? If lines are parallel, then alternate interior angles are congruent. So see, I've said just a ton of vocabulary now so that we're supposed to know and be able to apply in the next chapter. So that's what's also hard about the geometry is it's cumulative. We keep on using the same stuff we learned previously. So someone name me a triangle name for one of the triangles. I don't even care if it's the top one or the bottom one. PRS, okay? So you said triangle PRS. Now, I'm doing that on purpose because I want you to know that I'm not picking any special way to do the letters, but the way you just gave me, PRS, does now determine how I have to name the other triangle, okay? So you named PRS, which is the bottom triangle. What angle corresponds to where the P is in the other triangle on the top? Okay, so where P is, there's no mark on this triangle down here, all right? That would be where the R is on the other one. So it'd be triangle R, and then you went from P to angle, you went down here to angle 2. So I'm going from R, I have to go up to angle 1 where the P is. Okay, so it's going to be R, P, and then Q. Okay, that's very important to follow those letters. And that would be by, I got a side, and I've got the angle smushed between those two sides. So that's SAS. Okay. Now, if it helps for you to write S, angle S, angle S, SAS, they just happen to have a shared side. Okay, this one, you can mark sides that are shared into triangles, congruent to with themselves. So this one is actually, somebody tell me the top triangle, some help. And CAB, you want to spell a word? Sure, CAB. I get tired of doing ABC. CAB. All right, now, if I started with C and went to A, that side CA is double marked. So I need to find the side double marked down here. So it would have to be, since you went CAB, now down here, you've got to go CDB. Okay, so that's side, side, side. By side, side, side. Okay, now I'm going to show you why there is no donkey theorem. And, you know, it's not real appropriate for teachers to cuss in class, and so I'm going to say it one time that there's no S theorem. Okay? You can't do that. You can't say it, you can't write it. You're not supposed to have that on your paper, please. And there's no backwards one either, okay? So you can't do the naughty word theorem. There is no donkey theorem. All right, so I'm going to show you why it doesn't work. So on your paper, I believe I've drawn for, oh, that moved. I wanted to stay straight. Oh, come on. That's good enough. All right, so what my point is, I did draw for you already 2 sticks, 2 segments, okay, that are about like that. And then I drew an angle, right? And they were about like that on your paper, but they're matching. And their lengths right here are the same. And this angle is 40 degrees. Let's say it's about 40. I know it's close. Okay? So say that angle is 40 degrees, and then these segments are the same. So far I've got an A and an S. All right, I'm ignoring this side. So I'm going to show you why ASS doesn't work. So I'm going to go grab my mark pencil, and we're just estimating. I'm not making you measure. I want you to just kind of visualize what I'm showing you here. I can make this side go down to this segment this way or this way and be the same length. So what I'm saying is I can make a segment that goes like that, or I could have gone that way. So I'd do that on the other triangle. Are the triangles I just drew congruent? Not at all. All right, so that's what I want you to show on your paper. This side is congruent to this side, and we've got an A, an S, and an S, or SSA. S backwards. Okay, now I just recorded that, so I'm not, this is not for me to be being rude or anything, but I want you to remember, don't be, and I hope you understand, why is the A not, why is this not SAS? The angle is where? It's not between the sides that are congruent. It's not the angle between the sides. These angles are different. Okay, so you've got an angle and a side and a side, angle and a side and a side. They're all there. This doesn't work, so these are not congruent, right? They are not congruent triangles. All right, that's it for the ISN, please. Okay, so grab your packet, SSS and SAS, which I hope it'll work for you. Okay, so you know the two triangles are congruent if corresponding sides are congruent to all and the corresponding angles are congruent. The new thing today was the SSS postulate that lets you show that triangles are congruent even if you just know that all three sets of sides are congruent. So that's side, side, side. This is a picture of a side, side, side situation. There's three sets of sides that are congruent. That's why it's side, side, side. So let's decide whether a congruent statement is true or not, meaning these are saying they're congruent, but we're trying to determine whether this is true or false, okay, based on what we see. Now I see a 9 and a 9, which means JL is congruent to ML. I see JK and MK with 8s on them, so I know those sets of sides are congruent. And then there's a shared side between the triangle on the left and the triangle on the right. So that means that all three sides in both triangles are congruent. So this one would be yes, this is true. Okay, by side, side, side. That's good enough explanation. Okay. But look at the second one. I got a pair of sides. I have those two sides are congruent to one another. These sides are congruent. Do I have anything else? So I've got SS, and that's not a theorem. So this, you don't know for sure that this piece would be equal to that piece, even though it might look like it. This is not enough information. So this would be false, okay? There is not enough information. Only two sides, or you can write only two pair of sides are congruent. You don't know for sure. So you can't just base it on appearance. Oh, don't worry if you didn't write exactly what I wrote. As long as it's something like it. All right, let's try our first triangle proof. Okay, we're doing a 2-column proof. We've been given that AB is congruent to DB. So then you go to your diagram, and this is going to be really important for you to know which theorem or postulate you're using for proving triangles congruent. It will be important for you to mark your pictures. Okay, this has already been marked. I see that they have AB congruent to DB, and it's got slashes already provided. So then it says C is the midpoint of AD, which is another thing that's given. Okay. Now, what does that mean to you? If C, go to the picture, if C is the midpoint of A to D, what does it do? What does a midpoint do to a segment? So you got to remember what midpoint means. It's in the middle. What does that mean? It means that it cut the segment in half. All right, so that's why it says AC is congruent to DC. So I'm going to put single slash on those two. I want to mark my picture. All right, why is that true? Well, what did we just say here? That C is the midpoint. So that's the definition of a midpoint. All right, definition of midpoint is why you can say AC is congruent to DC. Now, why, and this is something we did already, it's another vocab word, why is BC congruent to itself? And I triple marked it. Anything is congruent to itself by what property? And you were about to say it, Darylyn. Reflexive. Not reflective or reflexation or whatever I've seen on some papers. It's reflexive. I've seen some very creative words. All right, reflexive. Okay, now that I have that, see how I've marked my picture? So what have I got? Well, I got triangles that are congruent by a side, then a side, then a side, which is the same over here. I got a bunch of S's, SSS, side, 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 postulate. And you only have to write SSS. Okay? Anybody still need this? Now, you don't have to put all the letters or S's on the figure. If that's not necessary, just trying to, hopefully you'll see what I'm doing. All right, now we're going back and doing side angle side. Side angle side congruence postulate says if two sides in the included angle of one triangle are congruent to the two sides in the included angle of a second triangle, then the two triangles are congruent. So in this example, if I say, okay, I don't care, someone give me a letter order for one of the triangles. I don't care which one. FE, I keep doing what Darylyn says. All right, F to E to D. She could have done DEF, she could have done FDE, but we did FED. All right, so what's important now, and that writing looks kind of cruddy. Sorry, I don't want anybody being confused about that. Okay, if I start with F, go to the other figure, what would match up with F? Yes, okay, so I know it starts with H. Okay, we went F and then we went across the double marked side to E. So I want to imitate that on the other figure. H, go to along the double marked side like we did here, F to E would be H to G, and then finally J. Okay, any questions about how I'm figuring out how to do the letter order? Now you can randomly just decide one of them first, and then you got to watch what you did to determine the other one. Okay. All right, this would be by the side angle side postulate, because you have a side and an angle between the sides. That's why this is S, then A, then S. Okay, and you do have to go to the closest next marked thing. You can't go this way and skip stuff. Okay. Okay, now hopefully this bad example or example that does not work will help you understand where the angle needs to be for it to be the included angle. Do you see the difference between this figure and this figure? This one has a side, an angle, wait a minute, and then it's got, wait, over here a side. You got to go the shortest route to get to the next marked thing, whether it's a side or an angle. So the shortest way to go spells a bad word. On this figure, though, you've got a side, then an angle, then a side. And now where's the angle? It's actually between the sides, okay? So this is a good one. This is a bad one. Do you see the difference? Does anybody not see the difference between those two? All right, in triangle ABC, I should have said good luck. In triangle ABC, she got that bowling. The angle is not included by the sides. Okay, this angle is not included between there. All right, and so the triangles cannot be proved congruent by SAS postulate, and there's no donkey theorem. Okay. All right, let's try another one. We got to fill in these givens. So JN's congruent to LN. KN's congruent to MN. And that was given. So we need, it's already been marked, I guess. Yeah, I check it out. It's already marked on the diagram. Now, you have to go to your picture and say, what else can I bring up? By looking at the diagram, is there anything else you could mark congruent that you know from previous lessons? Angle 1 is congruent to angle 2. That's why they wrote it. Why are they congruent? Yep, they are vertical. So that's either the vertical angles theorem Or you can just write vertical angles are congruent. But you need to mark it on your picture. Okay, you put this little arc mark on the angles. And then you say, whoa, the triangles are congruent. It's already stated in the proof. Why are those triangles congruent? What have you got when you look at the diagram? You've got a side and another side. All right, you got two pairs of congruent sides, and then in the middle of them is an angle that's congruent. So that's why this is side, angle, side. Okay. All right. Determine which postulate, if you can use one, that can be used to prove the triangles are congruent. If it's not possible to prove, write not possible. All right, whenever you look at a diagram, if there are things like a shared side or vertical angles, you need to mark them. So in number 1, you've got vertical angles, so we would mark them congruent. So far, what have you got? You cannot make up anything. You can't just randomly mark something congruent for no reason. So all I've got right here now, are there any reasons for us to mark sides congruent? Why? Because what? Okay, the slash marks on these? Yeah, okay, that I wanted to make sure I understood what you were saying. So you've got a side and a side. Okay. You've got an angle and an angle. Have we talked about anything that is just SA? So this is not possible. You can't add in anything that is not a fact that is congruent. It is a fact that vertical angles are congruent. All right, so that one's not possible. Now look at number 2. Is there something you can mark that's not already marked? You've got a pair of sides, 2 sets of sides, but then what about this thing? Chloe? 3 slashes here. Okay, good. Yep. Because that's a reflexive property. If you were doing a proof, you would write, I can say that because it's a reflexive. It's a shared side. So now this one is another side. That means we have a yes, and it's by side, side, side. Excuse me. Number 3, you've also got a pair of sides, another pair of sides, and you have a shared side. So we've got yes, side, side, side again. Okay. Now we're going to do a graph. Plot the points -3, 3, and label. We're doing 2 different triangles, -1, 3, and C, -3, 1. Okay, so that's that triangle. Now I'm going to do triangle KLM at 1, 4, 3, 4. M is at 1, 6. Okay, what do you think? Did we plot the points correctly? Okay, make sure you did. All right. What could we do? Do you know how long AC is? Okay, it's 2. How long's AB? What do 2 lines that are vertical and horizontal do when they meet? What kind of angle is right here? All right, that's for sure, isn't it? We know that. Okay, so does that happen on the right? The red triangle. So this side's 2. Okay, and this side's 2, and this is a vertical and a horizontal line, which make a right angle. All right, so I can say, determine whether they're congruent. Yes, they are. And that would be by, what do we got? We got a side, an angle, and a side. That's what we've proven. SAS. The angle between the sides is a right angle. Now, that's not the only way we could have done this one. We could have done the distance formula or Pythagorean theorem and found the length of these longer sides. But I thought that was easier for us to do side angle side on this particular problem. See what we can do on this one. So we got -4, -2. Plot your points correctly. The first number's left or right. The second number's up or down. -4, 1. -1, -1. These are further apart, so I'm going to grab my tool. Let's see if my pen will cooperate here. There we go. Okay, make the other triangle. 0, -2 is on the y-axis. 0, 1 is on the y-axis. And 4, 1. Oh, well, I think we might be able to tell pretty quick. Well, why? Let's show why, though. So we're going to do a little distance formula. One thing, this other triangle looks bigger than the other one, doesn't it? I can count the lengths of these sides. 1, 2, 3, 4. And this one is 1, 2, 3. If I plotted it right. Yeah, and then if I do the distance formula, all I'd have to do is show that 2 of these sides are not going to be matching. So I could do the length of BC. And that would be, real quick, just give me a second, please. 3 squared plus 2 squared. All I'm doing is counting to the right and then down. And that gives me 9 plus 4, which is the square root of 13. So they're not congruent because the sides are not the same length. Okay, I'd like you to continue working in that packets and be prepared with some questions. I'll try to go over the answers or ask questions from you guys tomorrow.